Today we're going to be talking about autonomous train operations, or ATOs, and we have an incredibly stacked panel, and I'm thrilled to introduce my panelists. We have Eszter Jósvai from Frequentis, Technical Solutions Manager. We have Oliver Reichard from Siemens Mobility, Nicola Furness, Principal Engineer at Network Rail, and Andy Billington, Innovation and Digital Architecture Senior Expert at Rail Baltica. So thank you everyone for being here. And before we get into the depths and of this topic, I was wondering if each one of you could give us maybe 1 to 2 sentences about your area of interest and expertise so that we have a better idea of the context that we'll be discussing. Maybe Andy, you can kick us off.
Yeah, sorry. Yeah, we are developing and delivering a completely new railway infrastructure. So we have to be flexible and able to cope with the new technologies and the new delivery and autonomous operation, which is going to come. If it's for specific fields, like, for example, a passenger train going from the depot to a station to start its mission, or shunting within a freight terminal, those kind of things are either autonomous or remote driving. So those two things are really closely connected. So we have to be able to cope with those things. So,
all right, Nicola, what is your specialty?
Well, I guess I come from a railway that already has ATO running on its mainline network. Thameslink in central London was commissioned in 2018, and we have automatic train operation with the European Train Control System in operation on passenger trains, meaning we can run up to 24 trains an hour on that network. So I'm very interested in both expanding ATO for capacity purposes, but also looking at long distance traffic and how ATO can support sustainability and energy efficiency.
Great. Oliver.
Yes, so my area of responsibility, I'm a sales manager. I'm leading a sales department in Siemens for Northern Europe and Eastern Europe and Middle East and North Africa. And for us, ATO, we look back to a long history. I mean, we have ATO already in the metro. I think a lot of you already know trains or have been in trains operating totally autonomously, like in Paris or in Nuremberg, for example, is a autonomic driving metro. What is challenging is putting this into operation on Mainline. We'll certainly come to that in detail. But we have the first rollouts, as already mentioned, Thameslink. We did this together. That was the first ATO over ETCS. I think we'll also explain what is ETCS later on. ATO over ETCS development in the world. We're looking at new projects, of course, Rail Baltica. And maybe I can give further on later examples, but of course from supply perspective, we are highly motivated now to implement ATO also on the main line.
Perfect. Eszter.
So last then, I'm Eszter Jósvai. I'm coming from Frequentis, and I'm Technical Solution Manager in the Public Transport Division. And how we are dealing with the autonomous train operations. So I was delegated to a European Union working group. The name is ATO. To summarize it shortly, so it's a follower project of the Shift to Rail. Shift to Rail was also a European Union project. The target was to sit together all the railway companies from Europe and make standardization for the autonomous trains. And this second follower project, this ATO, is for the moving block demonstrator, the moving block systems. Maybe we will touch it later, but the main target of this moving block that you can use your infrastructure, your existing track infrastructure in a much more effective way if you have the moving block and not the fixed block. And your important precondition to have also an autonomous train for that. But maybe later on we will also discuss this.
Certainly.
Details. Okay.
Yeah, thank you. And so it's already come up, but we can't really have this conversation without diving into the ETCS. So maybe, Oliver, you can give us an overview about the context of this in our conversation.
I'll try to make it simple. So we were mentioning about ETCS. This is a system that secures, on a very basic level, that secures the security on the tracks. Meaning we have fixed block. If a train runs into a block, the block is occupied, and so for following trains, the block will be signaled as occupied, and another train coming will have to stop automatically if the train doesn't do the stop by himself. We have this moving block. This is the future technology. So we're talking about currently the implementation is ETCS level 2. So it's basically a system that you can run without signals. And level 3 will be, we will have, instead of fixed block, we'll in the future have moving blocks, meaning the block moves together with the train. For this, you have to ensure the integrity of the train, which is quite complicated. When you come to freight trains, regular passenger trains, you can easily secure the integrity, but when it comes to freight trains, that is really a challenge that's going for the future. So this is the frame of ETCS. This is a European standard, and we use this European standard to implement ATO. So ATO is allowing us, within this frame, this umbrella, I would call it, of ETCS, to optimize the train driving, optimize the speed, the braking curve, in order to gain, to save energy, but also to optimize the throughput on the lines. Maybe just to give the, a summary about.
And maybe for the audience, this abbreviation ETCS, the European Train Control System, which is again a European standardization system. The goal is to replace the various legacy and not incompatible systems what the countries have now. So to across the border now, it's not so simple. You have to change the engine, the train driver, everything, because a couple of countries have the same signaling systems, but it's not the case in Europe. So therefore was this ETCS and these levels what Oliver has mentioned. And sorry, Andy. So the second base is why we are here in the 5G conference is the FRMCS. So you have two pillars for this autonomous trains. The first is the ETCS. The second one is the FRMCS and other abbreviations, Future Rail Mobile Communication System. It's a 5G-based dedicated railway communication system. And if you have this second pillar, then you have the 5G and this standardized regulation, then you can make this third step with the autonomous trains. So that's for the audience, these abbreviations, maybe it's much more clear.
So two components that are necessary to solve this uniquely European problem, that we have so many different legislations and regulations in a small space. And then when we have trains traveling into new countries, to make that possible for them to just keep going rather than having to stop, change drivers, change cars, and everything else that might be a hassle. So if I understand correctly, the ETCS is something relatively new. Is that right?
Can I take that one? Sorry, I think Oliver and Nicola are probably more qualified than me, but it's not that new. It's railways. It's taken quite a long time for it to be rolled out. One thing you'll find in rail, for those who are not familiar with the industry, it takes a long time to roll things out. It's an industry that is 7 years old, 7 years off being 200 years old in terms of international, intercity railway networks. Change is happening. It's a challenge because obviously if something's been working that well for that long, change has to be justified. And we have things, so for example, there was a question at another panel yesterday about artificial intelligence. How do you mathematically prove the AI model? A self-learning AI. You can't. So how do you roll that out in a safety critical network? You just can't. So there's a lot of it's not resistance, that's the wrong word. There's a lot of caution about how you do it. So ETCS is being rolled out, I think, in most of Europe and in quite a few other parts of the world.
Yes.
A lot of other places are modeled on ETCS. So Korea, for example. South Korea there is the Korean train control system, which is ETCS with some local modification. And they're using 4G because they could. Whereas when ETCS specifications were developed, the only option was GSM. So we have the railway-specific GSM-R, which is an industry-specific modification of a standard. We discussed before about that, whether that's a good idea or not. But you also have FRMCS, as Eszter mentioned, which is a successor standard. So the future railway mobile communication system, which is actually modular. So it will be 5G based as initial implementations, but the way it's designed is you can take the 5G radio and go, I need 6G now, or I need SAT, or I need Wi-Fi, or you can have both. You can have multiple comm channels. So the key is flexibility, and that architecture change is actually probably a more fundamental change than just the radio. The architecture change probably matters more.
Andy, as an architecture guy, of course.
Of course. I'm going to say that, aren't I?
And Nicola, you mentioned that you are already seeing ATO in action in Great Britain. And are you also running ETCS? What's that development looking like?
Yeah, we have a national ETCS deployment plan to fit our whole network. Yeah, as Andy has said, deployment can be quite challenging in the railways because changing technology is a big change for an industry that's so old. But I think introducing ATO was a big step forward for us. I should say the ATO we have in London is ATO with drivers in the cab, because there are different versions of ATO. You can have an ATO which is attended by the driver, so the driver is there monitoring what's going on and able to intervene if something goes wrong. But the future developments of ATO start to take the driver out of the cab, and that's where I think you get into some of the challenges of ATO about whether people are happy to travel on trains that don't have drivers in them. So certainly in Great Britain at the moment, we're sticking to autonomous trains with drivers. We're not prepared yet to take the next step.
Of course, and there are many grades, several grades of automation that we have to go through, similar as with autonomous vehicles, cars, and we're not talking about immediately jumping into just fully driverless, fully autonomous. There are lots of steps. But Oliver, could you tell us more from the industry perspective? Are you seeing interest? What is the benefit? How are you? What are the arguments for going autonomous?
I see an increasing interest from the industry. Maybe to give you some practical examples of customers that are looking specifically at ATO. I would give the example of high-speed California. So there is Brightline West. That is a project that is connecting Las Vegas with the vicinity of Los Angeles. And we will have trains driving roughly 240 kilometers per hour. And what is interesting will be in the middle of the highway will be one track in the middle of the highway with sidings so that, train can pass by one other. But if you have this kind of situation, you will need an automatic train operation. Of course, you have ETCS, there will be ETCS implemented, but with an automatic train operation, you will be able to calculate much more exactly when the trains can pass, when they have to brake eventually, when they can speed up again. Or, for example, in Switzerland, SBB, network operator for the Gotthard Tunnel, where this is 57 kilometers long tunnel, the longest tunnel in the world, where they want to have a throughput of an intercity train with 200 kilometers per hour, followed by a couple, I think 3 cargo trains, and then again intercity train. There also you need to monitor very closely, and you need to adapt the speed in order to allow these trains with a required frequency to get into the tunnel and to get out of the tunnel without having to brake, without having to use more energy than required. And what I think is also very interesting, we have a project in Hamburg now, a second project in Hamburg, because we implemented ATO over ETCS also in Hamburg with a regional network together with Deutsche Bahn. A second project where it goes even more about energy efficiency. The energy efficiency, we have estimates or proven estimates that 30%, even SPB once calculated 37% maximum of energy efficiency you can have with these ATO systems. And there, what is especially there very interesting for Deutsche Bahn is if you have a dense network with a lot of trains running at the same time, you reach a maximum, a cap of energy every time you have all trains starting, several trains starting at the same time. So with ATO, together with an intelligent train management system, ATO can allow you to defer the start of the trains in order to avoid to reach this peak of energy, because that's where you pay the most for the energy when you reach these peaks. Yeah? So lots of different examples where you can see, and especially I think, Andy already mentioned it, driving a train from the depot to a platform. If you have a train driver that drives the depot from the depot to the platform, somehow half of the time is wasted, because then he has to walk back by taxi, by bus, whatsoever, and he's not efficient in that time. So the most efficient you can have is to have a train that autonomously starts and goes to the platform, is ready on the platform without the train driver having to run back and forth between the depot and the platform. This is also tested now in testing phase with Deutsche Bahn, together with Bosch. Also, there, of course, you also need trains with sensors and cameras. That's where we come back to 5G, where you need broadband that allows you to transfer all these data. But this is what we currently have. So this driving to the platform, I would say, is the very first we see where we have this GOA4. This is the maximum where you have a train running without a driver, where we can see that it's starting to be implemented. Currently, it's more ATO level 2, GOA2, but here we have the first implementations of a future GOA4.
I think it's maybe worth just focusing a little bit on the energy efficiency thing,
Please.
because I'm sure most people have ridden on a train and the train sort of travels at speed and then it stops outside the station because it's running early. And the passengers get quite frustrated because the trains stop there. Well, when you're running with ATO, the system on board the train will detect that the train is running early, and so it will slow the train down. So the train will arrive perfectly on time in the station, and the passengers will be happy, hopefully, because their train arrives perfectly on time, but you'll have saved some energy because the train will have travelled at a lower speed because it doesn't need to fully accelerate and use that energy. So there are some real benefits both to the passenger experience and also to energy saving from using ATO.
I think, just if I may, just to add to that, there are some people in the room that I know have travelled on ATO controlled trains, Thameslink in particular, but also the Docklands Light Railway in London, which is a constrained network. It's not ETCS, but it has autonomous operation to an extent. They are manned trains. There is a passenger service attendant on the train, but the train can actually run completely unmanned if necessary, or unstaffed, sorry. But one of the things that's a key feature in the DLR and in Thameslink, I believe, is the energy efficiency. The train can decelerate when needed to meet timetables, so the timetabling is more accurate. It saves energy, and also the system that controls the trains is aware of the energy usage. So it can actually say a train that's braking can regenerate energy, because obviously, you have kinetic energy. Trains are quite big, quite heavy. There's quite a lot of mass. When you decelerate, you regenerate energy. You pull energy back from the system, and that can be fed back in. If you have ATO integrated with your energy management, you know what's happening. You can predict that energy surge. So you're not saying to a power grid, here's a load of energy, cope with it. You're saying, this is coming soon. Please be ready. And you can regen, you can circulate the energy. I mean, in a metro system, it's relatively simple to regen that into the next train. In a mainline, I think Oliver mentioned mainline versus metros or constrained systems. It's quite different because you have mixed traffic of freight, passenger, different operators in an open access network, which European trains are. It's more complicated to have that, but ATO and ETCS combination gives you the data you need to manage that. 5G gives you more bandwidth if you're moving more data, but actually from my point of view, the more important thing is the reliability, the resilience of the network, the greater security that you get from 5G compared with GSMR, where without giving anybody any ideas, you can go online and download the rainbow codes and find a way in. Let's not do that.
Maybe
So
we
you,
can hear from
yes,
Eszter.
of course, so the big advantages of the 5G-based FRMCS is the lower latency, the security options, higher bandwidth, because in case of an autonomous trains, you have really many endpoints and you have to deal with them. And maybe this is the point where maybe it's not clear for the audience what is the key difference between a self-driving car and an autonomous train, that the logic is somewhere else. A self-driving car makes decisions alone, but the autonomous trains has an onboarding unit, which is an onboard computer. And this communicates with the external systems, the train management system, what Oliver has mentioned, also the trackside assets. And these external systems schedule these trains. Therefore, you can solve also this moving block problem because all the trains are scheduled from a centralized management system. And of course, then you can also handle the acceleration and speed problems. Because you will know, not you, so the central logic will know how can you stop, how can you give speed or not. So that's the idea behind that there is two different decision background. The autonomous train is always part of a big network, and therefore, of course, you need a good bandwidth. So, and another benefit, of course, we did not talk, maybe political correctness, no idea about the human drivers. And I know exactly that now we will, I think in the next years, this grade of automation 4 or 3 will be the happiest scenario, that the train driver is there, but just checking the engine. But if you don't have really the human driver, then you can have really many idle stated trains. And if the passenger needs is there, then you can just start them. You cannot do this with the human drivers. You have to think on the schedule, on the working hours, on the trainings. We have also talked that even less and less young people would like to drive the train. So it's also an issue for the future. And so I know that, and I think we will talk about the regulations. So it's now, not tomorrow, will happen that we have no train drivers, but it brings also many benefits. But because at the end of the day, you are more flexible, so based on the passenger needs. And of course, you can use your existing infrastructure on a much better way, because that was what Oliver has also mentioned, this moving block technique. If you have a 2-kilometer fixed block, then the next train can never enter this block. You have maybe lose this 2 kilometers from your infrastructure. And I don't think so that the countries will build new infrastructure. So you can use your existing one on a better way if the fixed blocks are disappearing, and you can handle with this external but centralized system the trains after each other, of course, with a security distance. At the end of the day, it's then I hope that it will be more attractive for the passengers and also for the freight transport. And then you can reduce the emissions, and then we can tell at the end that, okay, maybe we have done something for the climate.
Of course. So it sounds like we are talking about a lot of benefits. My question then for the panel, and I don't know who wants to take this immediately, is why aren't we there yet? What are the challenges that are keeping us from implementing this beautiful future of autonomous trains that are green and great for the people?
Can I take a general point and then hand over to specialists? Eszter mentioned moving block and fixed block. Just to clarify for the audience, because I think this audience is more telco than rail in terms of the engineers who are in the room.
But hello to everyone who's viewing online. We don't
more
know.
than welcome. And please come and join the rail sector. So from the moving block and fixed block sector, I think the simplest analogy is fixed block is a section of track that no one enters because someone else is there. Moving block is an area around a train that no one enters because a train is there. So I think Nicola will probably correct me, but the IT analogy is basically, do you have a fixed server and it's in it, it lives in its home and no one is allowed to go near it? Or do you have a container or a virtual machine that could migrate from place to place and no one goes near it? But that's a really bad analogy.
Well, thank you for clarifying it.
but it's that kind of, that's the distinction. So if you can see the thing that moves, having a safe area around it actually creates more space, creates more opportunities, creates more traffic is possible on that space, because you're not saying, I mean, you maybe, for example, and from my own experience, London Underground will say train cannot go within 700 meters of the train in front of it. They won't say a train cannot enter that section of track. Or some of the lines anyway. Some of the lines are somewhat old. But in general, it will say you can't enter that zone of protection around the train. But one of the things that's been an issue is, how do you get reliable connectivity? So GSMR has been in use for 20 years, maybe more than that in some places. But it is GSM. It's a railway-specific version of 2G. So the need to migrate from that has been recognized, and most of the industry suppliers, and I have two colleagues on the panel who are industry suppliers, have said, we're not that happy with supplying, supporting, sustaining this older technology. And then the industry itself went and said, hang on, if we can have more data, but more importantly, more reliable communications, more lower latency, or all those things, we can also do things with sustainability, with energy management, with whether it's GOA2 for, okay, GOA2, you have a driver. The driver says, yeah, train, you're good to go now. GOA4, no driver. GOA3, you have someone on the train.
Yes.
So for those who, again, I have to use a UK example, I'm sorry, but for those who are familiar with London, Docklands Light Railway is GOA3. You have a passenger service attendant on the train. They can drive the train from anywhere on the train where there is a control panel. They don't need to be at the front.
Thank you, Andy. In the interest of time, I want to get to the question about the challenges and why we're not there yet.
Well, I can start. I think you go back to the question of ETCS. Europe is rolling out ETCS across the network. There's a European ETCS deployment plan. and every member state has a plan to move to ETCS deployment. So that's the first step. You need ETCS as a foundation for your mainline railway. Then on top of that, you can add ATO. And we've needed some standards to be developed to make sure that ATO is interoperable, so to complement ETCS. And just this year, earlier this year, the standard CCS technical specification for interoperability was published by the European Rail Agency, and it now contains specifications for ATO grade of automation 2. So that's automatic train operation with a driver on board. So we now have some standards available for all the railways and suppliers to use and implement to make sure we have an interoperable ATO over ETCS system. So that's an enormous step forward, and the standards were developed through the European project Shift to Rail, which Eszter mentioned earlier.
Nicola, how long do you think it will take for European countries to implement ECTS?
Probably quite a long time, because railways, we've already talked about, railways have quite long investment cycles. And so I think now the standards are available, countries will be looking at, right, we can start planning our implementations. I think railways that have real capacity problems, railways that have big shunting yards to look at, are probably going to be those that start pushing implementation forward faster than others, but I can't give a timescale, or I wouldn't like to guess.
Fair.
I think there's now a legal basis for people to do it, though, because before the standards were ratified,
yes,
there was a legal problem.
Right. So finally, we have the foundations to at least practically start moving this forward.
Yes.
Oliver, maybe you want to give us a comment.
I would add on that, exactly. Standardization is key. We were talking about ETCS. ETCS has been implemented. It's one ETCS, but actually it's 27. I think we're 27 member states. I counted right. 27 different.
It's a sore point.
I wasn't sure if I have to count now 26 maybe. So in the end, even if it's standardized, each country still has its own specification, which leads to us as suppliers, we have to implement these specifications. It takes more time, needs to be checked, needs to be approved. And so I think we'll need to learn from the past and to make it better in the future, that we have a standardization that avoids that we have different functionalities in each and every country. And this is especially, I'm looking now at the outlook for GOA 3, GOA 4, where we're still working on the specification, that we will have one specification, that there will be one process, one approval system somehow that will make it much easier to implement than if we have, again, 26, 27, correct me if I'm wrong, national specifications. So, as I said, standardization, that is key for the industry and I think for the network operators as well.
And Eszter, what are you seeing?
Just somehow point out from this situation, it could be that it's also a big step, also not just for the standardization. I know this all country has an own regulation and so on, synchronizing, harmonizing, but it could be that the society is also not prepared to travel with the autonomous trains. So I see this, okay, I know more than 100 years ago, our only option was to ride the horses, I know. And after that we got the cars and the public transport. But thanks for the regulation, now it's part of our life and we can handle this worldwide. Then now we need rework these regulations, update. Also, the society has to accept this new philosophy, because I remember the first talk with Annie that what will happen, self-driving cars and autonomous trains and everywhere. So it could be that is also a huge step, as 100 years before, between the ride the horses and have the public transport. It could be that also in the mines it is a big step, not just missing regulations and standardizations are missing. So the working group are working groups are there in Europe, and I think the US has also already started. So it's not that we did not nothing, but the acceptance from the society is an open question.
Right. So we have not only a technical and a regulatory
Yes.
challenge, but also a human challenge as well.
Yes, that was also the question from on the end. Who will travel with this?
Exactly. And we'll be looking forward to seeing the results of the poll at the end to see if our viewers, who are arguably very open to new
More tech
technologies,
savvy.
would be more willing to drive with an autonomous train.
But I think there's also a point that touches on something that both of Oliver and Eszter said from the supplier side. It's ETCS. It's the European Train Control Standard, which is now being implemented in California.
Lots of
version
Egypt, Algeria,
in Egypt, in
Australia,
Algeria,
Saudi Arabia,
in
lots of
Australia,
countries, yeah.
in Korea. No, it's not actually a European. Well, it is a European standard,
We like
but
calling it.
it's basically pushing out everywhere because the supply chain needs the certainty of standards. And if a standard works for 28 countries, it can be made to work for a lot more. And that's, I mean, GSM was deployed in all sorts of places where it was not actually legally intended, but it worked. So people did it. And ETCS is the same. ETCS ATO will almost certainly be the same over time. It might take a little while, but it's there.
And that will make it possible for us to travel wherever we want, smoothly by rail.
Yeah.
What a beautiful future.
And in some cases, you might not even know it's an autonomous train. I mean, DLR, most people don't know there's no driver. Unless they grab the front seat at the beginning of the train and feel that they're the driver.
I think a lot of people would really enjoy that experience.
Oh, everyone.
We are nearing the end of our panel, and therefore we have time to open up to the floor to questions from the audience in person. If we have anyone here, then we also have questions online.
Yes, we do actually. Regarding that poll, would people feel comfortable riding autonomous trains on main tracks? And the majority, more than 70% say yes.
There we go.
Perfect. The society is
No more human travel.
fine.
That's our audience. Thank you for that. Thank you for the openness. Yeah, we have actually 4 questions that came in through the platform, so we can, I think, manage them all and have questions from the audience in this room. Let's be very short on answers, I believe. The question to Mr. Billington regarding RB Rail. So how could the 5G network required by RB Rail be technically provided, and what business model do you see to operate it?
Okay. Slightly complicated question, so I have to be cautious. In terms of rail control and systems, it has to be a closed network. We can't share the railway safety critical control with third parties. That's not an option. How that's done technically, I think you can do it with 5G and slicing, but whether the regulators allow that is a very different question. And so we have to balance regulation, safety, and economics.
All right. Next question. 5G is known, and upcoming 6G is known for low latency, very high throughput, ultra high reliability, massive access, and so forth. So which one of these features are most relevant to autonomous train operations?
Reliability.
Reliability.
Sorry to jump in, but
Yeah, definitely.
All right.
Agreed.
Okay.
Unanimous decision.
About the reduction in energy consumption, you touched upon that. Any projections? If we implement autonomous trains, what would be the reduction, percentage-wise? Or
Maybe you can take this. So there had been analysis run on operating networks with ATO over ETCS, and the energy consumption, I think I mentioned it earlier, is can be up to 30%. You can never really give a fixed figure because it also depends on the circumstances, on tracks, on various specifics. But the practice has shown that even SBB, as I said, they calculated it would be even more than 30% in certain circumstances. So we can see a significant reduction of energy here in.
Just to clarify, just from what Oliver said, the metro experience of ATO in the closed network, you can have between 20 and 40%, but it depends how many people are on the train.
Sure.
Yeah.
If you look at London Underground,
We'll know then, right?
Yeah.
We'll know it.
how heavy is the train is the determinant.
But also, I think Nicola has experience with this. What does your experience show you?
It depends on the network. It's hard to put a figure on it. You've got to do the studies on a specific network because
And time of day.
time of day, loading of trains, type of train, capacity, numbers of trains on the line. But I think the figures we've talked about are sort of an up to 30% is probably a good
Right.
coverall
One third.
figure.
1/3 sounds fair.
That's significant.
Yeah,
It's a
very
pretty good
It's
number.
quite impressive. Yeah. One last one from online audience. Oh no, two last ones. I'm sorry. Updated. Any examples of trials or pilots on the integration of ATO with 5G or B5G networks? Existing trials? You do know?
I think if the 5G rail, UIC's 5G rail has done ATO pilot in the test lab in Germany.
What for sure is the current project for Hamburg that is running with Nokia is providing that on the 5G network, on the public network.
They just erased the last one. I'm not sure. What was it? I mean, censorship, maybe. I don't know.
Maybe
All
it
right.
was already answered.
Maybe, yeah. So, any questions in the room? You go home and you say, I was in a conference and I spoke in a microphone. Well, that's, why not? Then probably final reflections on topic.
Well, certainly. And maybe we can do a very quick one sentence from each of you on what you see the future to bring, but very briefly. Andy?
Very briefly, and she answered me. Oops. I think that there are two things. One is there is a skills shortage in the industry, and that's becoming increasingly obvious. The other thing is the energy savings. If you're looking at 20%, 30% more, that's significant. We should grab it. That's a big sustainability goal that, particularly for us, for new infrastructure, we cannot ignore. We have to do that.
Perfect. Thank you. Nicola?
I'd say if you're buying new trains now, fit them with ETCS and ATO. The standards are there, the products are there. So we should be moving to an ATO railway now.
A note to self next time you buy a train. Oliver?
I would go the same direction. I think you can, even sometimes if you see customers that are still a bit reluctant on implementing future technologies, you can always prepare your technology for the future. Prepare the trains, prepare the infrastructure to be able later on to upgrade to ATO level 2, maybe also level 3 and level 4. And I think it's very important also to mention that we are facing networks that are getting to the limit of their capacities. It's, we can build further tracks that cost a fortune. We can build further tunnels in Switzerland, cost a fortune. So we need to use the technologies we have on hand today and the future technology that will be developed to enable to maximize the capacity of the existing network.
Thank you. Eszter?
I can just say the same, but with other words. So I would like to see Europe in a form where you can just go across with the engines without stop, without change the train drivers, or with the autonomous trains, you can solve also the language problems. And of course, with the ETCS, you can solve the variable signaling systems. So just going from the east border to England across without any problems because of the differences in Europe. So that's my vision.
And just a quick
Oh,
follow-on. If you look on the Thalys system going from Paris to Amsterdam, I think those trains have 7 different signaling systems to go with.
Yes, that's the problem.
Yeah. So from an IT point of view, from a telco point of view, think about 7 different standards to manage.
Never ever.
Yeah.
So,
All right. Thank you very much to the panel.
Yes, and thank you for wonderful moderation to Julia. Thank you so much.
Thank you.
Oh, no.